All right, welcome everybody. Today we're going to talk about lesson number 55. This is still section 4.5, integration by substitution. And today we're going to formalize the process of how you would actually use what's called U substitution. If you compare this to lesson 54, which you'll remember was pattern recognition, this process, while it takes a little bit longer, it tends to be a little bit more definitive. It's a little bit more black and white. And even though it will not in the future tell you you have to use this method versus using pattern recognition, most people prefer this method, especially as the problems get more difficult, because again, it just streamlines the process and gives you a go-to series of steps. This is homework 55, which you'll want to write down right now. It's section 4.5, page 301, and those 5 problems. And again, we are going to recommend that for this homework, you do try using U substitution for all 5 of those problems, just to make sure that you get used to the process. Please note that there is no worksheet for today's lesson because it really is only a couple of problems, and then you'll have plenty of room in your notebook to kind of keep up with it. So this process is now using what we call a change of variables. So basically, you are going to completely rewrite the integral in terms of u and du. That's instead of x and dx. This process generally has more steps than pattern recognition, but it's useful for harder problems, which we're going to see on day 3, day 4, and day 5. You'll remember that when you were doing pattern recognition, you were looking for the composite function f of g. You would identify the innermost function g, and you would look outside to see whether or not the derivative of g was present. If it was present, you would integrate as per usual. If it was not present, then you had to go ahead and make a compensation. That process is similar for U substitution, except for the fact that you are going to rewrite your function as f of u. You're going to be looking to see whether du is present, and then whether it is, you're going to go ahead and integrate as per usual, making any compensations as needed. And of course, you're going to continue to add plus c as long as these integrations are indefinite. So here's our first problem, and I would remind you that as you take notes on these, please feel free to pause the video at any time or to go back and watch as many times as you might need. So for number 1, this is the integration of 2x minus 1 dx. Again, remember the dx has to be there in order for the problem to work, and it definitely has to be there for the steps that we're going to be doing today and going forward. So in order to change the variable to u, what you're going to do is you're going to identify the innermost part of the function, or the more complicated piece, which in this example would be inside of the radical, which would be 2x minus 1. You're basically looking at this function and saying something is being raised to the 1/2 power. Whatever that something is, that would be your u. So once you identify whatever you think u is, you're going to go ahead and set that up. So u is equal to 2x minus 1. You are then going to take the derivative of u equals 2x minus 1. For this first example, I'm going to show you all the steps, and then for the rest of the examples, we're going to kind of cheat a little bit to save a step. So u equals 2x minus 1, you are being asked to take the derivative in terms of x. So if you're taking the derivative in terms of x, when you take the derivative of u would be du dx. The derivative of 2x in terms of x is just 2. The derivative of a constant is 0. What you want to do next is you want to take your du over dx equals 2, and you want to solve it for dx. So you're going to go ahead and cross multiply. Then you're going to solve for dx. So dx would be equal to du over 2. Now that you know what u is equal to, and now that you know what dx is equal to, you are now going to rewrite this problem all in terms of u. So this problem is now the integration of, instead of 2x minus 1, you are going to use u, which makes this problem the square root of u. Then dx is equal to du over 2. So you are going to make that replacement. In order for you to best integrate this, there's a little bit of simplifying that you want to do. You are going to factor out the 1/2. That would take the square root of u, and you would write it as u to the 1/2. du. After you've done this simplification, if you've done it correctly, there should only be a problem in terms of u's and du's. As long as you have a problem only in terms of u's and du's, then you're allowed to go ahead and integrate like we normally would. So the way you would integrate 1/2 u to the 1/2 du is to leave the 1/2, take the u, raise it to the 1 higher power, which would be 3/2. Don't forget to divide by that power. Now you're going to go ahead and do a little bit of simplifying. So 1/2, and then because of this 3/2 on the bottom, if you multiply by the reciprocal 2/3, you're going to get 1/3 u to the 3/2. After you have done all the integration and after you have done all the substituting and simplification, you're now going to give your final answer by going back and rewriting it in terms of x. So your final answer to this problem is 1/3. You're going to take the u, change it back to what it originally was, 2x minus 1 to the 3/2, and then in the end, don't forget to write the plus c. So your final answer for the integration of the square root of 2x minus 1 dx is 1/3 times 2x minus 1 to the 3/2 plus c. As always, remember that you could check your answer by taking the derivative of 1/3 2x minus 1 to the 3/2 and making sure that you get the original problem. Don't forget the chain rule, of course. So that's number 1. Let's go ahead and take a look at number 2. So number 2 is the integration of 3 times 3x minus 1 to the 4th dx. So every piece that we need to get started is here. And our first order of business is to go ahead and identify the u. Again, the u is the innermost function, the more complicated piece, which in this case is 3x minus 1. So u is equal to 3x minus 1. This is where I'm going to kind of show you just a little cheat step. Instead of doing du dx and then cross multiplying, here's what you can do instead. If you were going to take the derivative of u equals 3x minus 1, the derivative of u, we're just going to call that du. The derivative of 3x, we're going to call that 3 dx. And then the derivative of a constant is always 0. And again, all I did here was save myself the trouble of having to do the cross multiplication step. So if you want to use my little cheat going forward, feel free. If you don't, that's fine as well. Remember, you have to solve for dx. So dx is equal to du over 3. You then want to go back to the original problem and you want to rewrite everything in terms of u. So the original 3 from the problem, you're going to take 3x minus 1 and rewrite that as u to the 4th. Rewrite dx as du over 3. Look at that, magic. The 3's happen to cancel, which is always nice. This now becomes the integration of u to the 4th du. As long as you are left with something only that has u's and only that has du's, then you're welcome to integrate like we always would. So the way that you integrate something to the 4th power is to rewrite that something, in this case u, to the 5th. Don't forget to divide by that same power. Once you've done your integrating and you're simplifying in your final answer, go back to x's. So 1/5. Instead of u to the 5th, you're going to rewrite 3x minus 1 to the 5th. And then, of course, in your final answer, don't forget the plus c. Again, you could very easily check that this answer was correct by taking the derivative. Remember, if you're having trouble following along, please feel free to go back or to pause or to send your teacher questions in the chat message. We're always welcome to assist you. All right, number 3, the integration of 3x squared times the square root of x cubed minus 2 dx. Take a second to look at this and think to yourself, where would the u be? The u always has to be an inner function, and it always has to be part of the more complicated piece. So if you were to compare 3x squared to the square root of something, hopefully you would agree that the square root is the more complicated piece. That means that my inside function here, that would be my u. I'm going to take the derivative of u and call that du. I'm going to take the derivative of x cubed and call that 3x squared dx. The derivative of a constant is gone. Solve for dx would be equal to du over 3x squared. Go back to the original problem. The 3x squared was already there. Instead of the square root of x cubed minus 2, you are now going to write that as a u. And then dx is equal to du over 3x squared. Again, we can see that life is good. The 3x squared cancels out with the 3x squared, which means all that I'm left with here, give me a second to make sure, okay, is the integration of u to the 1/2 du. You, of course, want to rewrite your square roots as 1/2 powers. How do you integrate something to the 1/2? Well, you're going to raise it to the 1 higher power, which is 3/2. You're going to divide by that same power, which is 3/2. For your final answer, multiply by the reciprocal to give you 2/3. Rewrite the u back in terms of x's. So x to the 3rd minus 2 to the 3/2. And don't forget the plus c. As we move forward with more examples, remember at any time you can look at the problem, pause it, try it yourself, and then tune back in to see if you're doing it correctly. Problem 4, here's our first fraction. We don't really like those fractions. We prefer them to be multiplications as opposed to being divisions. That means that we are going to always want to take our denominators and move it up to the top. And when you do that, you have to make sure that you are using a negative exponent. So in problem 4, the very first thing that I'm going to do here is I'm going to rewrite it so that there is no longer a denominator. So I'm going to rewrite this problem as the integration of negative 4x, 1 minus 2x squared to the negative 2 dx. Then I'm going to continue the same process I've been doing. I'm going to look at my problem. I'm going to look for what I think is the more complicated function, and I'm going to identify the inside function, and I'm going to make that u. So u equals 1 minus 2x squared. Derivative of u is du. Derivative of a constant is 0. Derivative of negative 2x squared would be negative 4x dx. You have to solve for dx, which would be du over negative 4x. Can't really draw my 4 there. Okay, so now we are going to rewrite this problem as the integration of, leave the original negative 4x, change it into u to the negative 2. Dx is equal to du over negative 4x. And then go ahead and simplify. So the negative 4x from the top cancels the negative 4x from the bottom, leaving this as the integration of u to the negative 2 du. Now, if you're wondering if these problems are always going to be that nice where everything's always going to cancel, no. For today, the variable x will always cancel. So if it doesn't, that's a problem. But the constants do not have to cancel, so that's just something to keep in mind. So how do you integrate something to the negative 2 power? Well, you have to raise it to the 1 higher power. And of course, remember that 1 higher than negative 2 is actually negative 1. So this becomes u to the negative 1. Don't forget to divide by negative 1. If you were to simplify that, that would actually become negative 1 over u, which means your final answer to this problem is negative 1 over 1 minus 2x squared, and then don't forget the plus c. Couple more examples left. So again, feel free to stop, redo the problem, go back, rewatch anything that you're having trouble with. Problem 5, we see here that we have another fraction, and not only do we have a fraction, but we also have a square root. So when we rewrite this problem, I'm going to rewrite it not only with a negative exponent, but I'm going to change my square root into a 1/2 power. So this becomes the integration of x cubed times 1 plus x to the 4th. Because I'm moving 1 plus x to the 4th to the top, and it was a square root, that makes this a negative 1/2 dx. So as we've seen throughout most of the year, the rewrite step is usually the most important. So now that I've rewritten my problem, take a second to think about how I would identify u. Has to be part of the more complicated function, and it has to be inside. So my u would be right here. U would be equal to 1 plus x to the fourth. Derivative of u is du. Derivative of a constant is 0. X to the fourth becomes 4x cubed dx, which means that dx would be equal to du over 4x cubed. Let's go ahead and rewrite our problem. So the integration of the original x cubed, change your problem to a u to the negative 1/2 power. Dx is equal to du over 4x cubed. We have a little bit of cancellation in the variables, which again should always happen, at least for today. We don't cancel the 4 on the bottom, however, which means this is the integration of 1/4 u to the negative 1/2 du. Perfectly fine to integrate with that constant 1/4. Just don't forget that it's part of the problem. So as I go to actually integrate now, leave the 1/4. Raise u to the 1 higher power. 1 higher than negative 1/2 is positive 1/2. Don't forget to divide by that power. Because on the bottom you have a 1/2 and you also had a 4, this actually becomes u to the 1/2 divided by 2. 2 is what you get if you multiply 4 times 1/2. So for your final answer, you're going to go ahead and replace the u with 1 plus x to the fourth. And whether you leave it as a 1/2 power or a square root, it doesn't really matter. Let's say we make it a square root. This would become the square root of 1 plus x to the fourth over 2. And then as always, plus c. I would say that these fractional problems are probably the most difficult, at least for now. So again, take your time, go back, do some practice. Our final problem for this lesson is number 6. Notice that instead of x's, it's t's. It doesn't matter what the original variable is. The idea of u substitution is you're always going to change it to u's, and then you're always going to go back to the original variable in the end. So from here, go ahead and identify the u, which would be the innermost function. So u is equal to 2t to the fourth plus 3. You would go ahead and take the derivative of u. The derivative of 2t to the fourth would be 8t cubed, and then instead of dx, of course, it's dt. In this case, you would want to solve for dt. So dt would be equal to du over 8t cubed. Rewrite this problem as the integration of, leave the original t cubed, change my problem to u to the 1/2 power. dt is equal to du over 8t cubed. Variables cancel as they always should for today, which means I am left with the integration of 1/8 u to the 1/2 du. Perfectly fine to integrate a problem like this, as long as you don't forget that the constant is part of the problem. So when I go to integrate, I'm going to leave the 1/8, raise u to the 1 higher power. 1 higher than 1/2 is 3/2. Don't forget to divide by that power. On the bottom, you have 8 times 3/2. That becomes 24 over 2, which becomes 12. So this is u to the 3/2 over 12, which means in your final answer, you're going to get 1/12. Replace u with 2t to the fourth plus 3 to the 3/2 power, and then don't forget plus c. So 1/12, 2t to the fourth plus 3 to the 3/2 plus c.